So, good evening, all of you. So, now in today's series, in PGT lecture series, I will start with new topic, that is electrostatic potential and capacitance. This is the second topic of electricity and magnetism. But now I have slightly changed the program, that instead of deriving everything, I will give you the summary of the different topics, and then we will focus on problems, because in exam mainly they will give you problems. So that's why I have designed this practice set where I have summarized this chapter, and we will share this PDF file. We will share you in your WhatsApp group, as well as it will be given in the link of in the description link. You will get this particular PDF file. So I have summarized everything, and then we have, based on this, we have given you different questions. So through problems only we are going to revise this chapter. ठीक है? तो हम मेनली अब प्रैक्टिस सेशन पे डिस्कस करेंगे. हम इंपॉर्टेंट कॉन्सेप्ट्स और फॉर्मूले आपको रिवाइज कराएंगे, और ये रिटन फॉर्म में भी दिया हुआ है. जस्ट सी हियर. और इन्हीं के बेस जितने डिफरेंट टाइप्स के प्रॉब्लम हो सकते हैं वो सारे हम डिस्कस करेंगे. ठीक है? तो अब जो भी लेक्चर्स होंगे उसमें हम मेनली प्रैक्टिस सेशन पे फोकस करेंगे, सो दैट यू कैन सॉल्व डिफरेंट टाइप्स ऑफ प्रॉब्लम्स. ठीक है? तो ये पहले हमारा चैप्टर 2 है. लेट्स सी. इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटेंस. So let's see the syllabus of this particular topic. Let's see the syllabus. What type of questions they will ask. So in this particular chapter, we will focus on calculation of electrostatic potential. तो हम पहले पोटेंशियल के क्वेश्चन देखेंगे. इलेक्ट्रोस्टैटिक पोटेंशियल. ठीक है? कैलकुलेशन ऑफ इलेक्ट्रोस्टैटिक पोटेंशियल. Potential due to point charge, potential due to point charges, potential due to point charges. So you have single charge, you have more than one charge, what will be potential? Then potential due to electric dipole. ये सारे फॉर्मूले आपको पता होने चाहिए. पोटेंशियल ड्यू टू इलेक्ट्रिक डाइपोल. ठीक है? Then you must know what is इक्विपोटेंशियल सरफेस. इस पे भी क्वेश्चन आ सकते हैं. इक्विपोटेंशियल surfaces. Equipotential surfaces. Then next will be potential energy of a system of charges. Potential energy of a system of charges. ठीक है, potential energy of a system of charges. Potential energy in an external field. Potential energy in an external field. External electric field. इसके बाद हम देखेंगे, we have already discussed conductors. Now we will see dielectrics and polarization. Dielectrics and polarization. So these are the different topics on which question may be asked. Then you have capacitance. We will talk about capacitor and capacitance. Then we will see, in capacitor, we will talk about mainly the parallel plate capacitor. The parallel plate capacitor. Parallel plate capacitor. Then effect of dielectrics on capacitance. On capacitance. Effect of dielectric on capacitance. Combination of capacitors. Series and parallel combination. Combination of capacitors. ठीक है, और फिर एनर्जी स्टोर्ड इन अ कैपेसिटर. Energy stored in the capacitor. ठीक है, so this is the syllabus of chapter electrostatic potential and capacitance. So question may be asked on these topics. Clear? So first you should know the syllabus for each particular chapter, so that you should know on which part question may be asked, and then you have to write their summary, important concepts and result, and then you have to solve the problems. So note it down. ठीक है? So in today's lecture, let us first see the summary up to this part, potential energy in an external field. So in today's lecture, I have taken problem up to this part. So let's see the important results. I will share this file in your WhatsApp group, as well as it will be given in the description box, so you can download from there. So you know that electrostatic force is conservative in nature. In conservative force क्या होते हैं? So work done in moving a charge from one point to another point is independent of path. It only depends on initial and final position. So, and what is the the work done by an external force equal and opposite to the electrostatic force in bringing charge Q from some point R to a point P is stored as its potential energy. So if you have, let's say, if you have some charge Q here and you are moving some test charge Q from point R to point P. So you need some external force because electrostatic force will be in this direction. So you need some external force to move some positive charge Q from R to P. And this work done is independent of path, and this work done is stored as its potential energy. So this work done is given by, it is stored as its potential energy, which is the difference in the potential energy of charge Q between the final and initial points. So this work done is given by, that is difference in potential energy UP minus UR. So this work done is stored as its potential energy. So because you have to do some positive work, if you are moving charge, positive charge against this repulsive force, so you need to do some positive work. So this stored energy will be positive, means you will see this UP will be greater than UP. At point P, potential energy will be more as compared to R. And if you are taking R to be infinity, so we will take its UR will be 0. And then that will give you potential energy at particular point P. So you need some external work to move a charge Q against the repulsive electrostatic force. So stored potential energy will be positive. If this charge is negative, then stored potential energy will be negative, because then negative work will be done by the external force. So that is the potential energy. Work done by the external force will be stored as its potential energy. Now what is the potential energy, potential at a particular point due to given charge Q? So it is defined as potential at a point is the work done per unit charge. So potential at any point P, if you are, let's say, is given by work done per unit charge. This is work done per unit charge. So this is UP minus UR by, this defines the potential. And if you are moving this charge from infinity, R is equal to infinity, so potential at R will be infinity. Potential at R will be 0. So that will give you potential at particular point P as simply work done in moving charge Q from infinity to point P. So potential is work done per unit test charge. This will be work done per unit test charge. And then if you have to find potential due to a point charge Q, this will be given by potential due to point charge Q is 1 by 4 pi epsilon naught Q by R. R distance away, this will be the potential. If you have n number of charges, let's see potential due to n number of charges. So if you have charge, let's say this is Q1. I am just giving you the summary and we will focus on problems, because you can easily summarize all those things. There is n charge and there is a point P here. So what will be potential? This will be R1P. This is R2P. This is RNP. So potential is scalar sum 1 by 4 pi epsilon naught Q1 by R1P plus Q2 by R2P plus and so on Qn by Rn. So find out potential due to individual charges and then take scalar sum. ठीक है? Clear? So potential due to single charge and potential due to n number of charges. Now we can generalize this for, let's see what will be potential due to electrostatic potential at a point with a position vector r due to point dipole of dipole moment P. So if you are taking, this is minus Q and this is plus Q, and this dipole is separated by a distance 2a. This is the center of the dipole, and this is point P, r distance away. This angle is theta. Let's say this direction is r cap. So its dipole moment will be in this direction. P is Q into 2a. So potential is given by, as a function of r, this will be 1 by 4 pi epsilon naught P dot r cap by r square, or this can be written as 1 by 4 pi epsilon naught P cos theta by r square. This is the potential. ठीक है? So this is the potential due to dipole. So at this point along the dipole, along the axis of the dipole, along dipole axis, theta will be 0 or 180 degree, and in the along the direction perpendicular to dipole axis, theta will be 90 degree. ठीक है? So you have to remember potential due to dipole. I am not focusing on derivation part, just remember the result and then you should solve the problems. So please note it down. Now, so now what is an equipotential surface? Equipotential surface is a surface over which potential has a constant value. When on a particular surface potential is a constant, that is called as equipotential surface. For example, if you have a point charge Q, so if you draw a concentric sphere centered at the location of the charge is an equipotential surface. Concentric sphere is an equipotential surface. And the electric field at a point is perpendicular to the equipotential surface through the point. And E is in the direction of steepest decrease of potential. If you know the equipotential, then E is in the direction of the steepest decrease of the potential. If you can identify in which direction there is steepest decrease in the potential, that will be the direction of the electric field. And on the equipotential surface, direction of electric field is perpendicular to the surface through a particular point. What is the potential energy stored in a system of charge is the work done by the external agency in assembling the charges. What is the total work done in assembling all charges? So that will give you the potential energy of a stored system. For example, if you have two charges, you have assembled two charges. So that potential energy is given by 1 by 4 pi epsilon naught Q1 Q2 by R12. This will be the total work done. And now you have to find what is the potential energy of a charge Q in an external field. So means you are moving a charge Q in an external field at a particular point R. So potential energy is given by Q into VR. And the potential energy of a dipole moment P in a uniform electric field is minus P dot E. So this is the potential energy of a charge Q in an external field, and this is the potential energy of a dipole in an external field E, minus P dot E, or it is minus PE cos theta. So now we will focus on question based on potential and electrostatic energy. So let's see. Let's start with. See question number. First, see question number 1. Try to solve. Try to solve question number 1. Try karo. Let's see question number 1. Take 2 minutes and try to solve it. So question number 1, calculate the potential at a point P due to a charge of 4 into 10 to power minus 6 coulombs located at 9 centimeter. It's a simple point charge. What will be potential? So you can easily calculate. So A part. So potential is given by 1 by 4 pi epsilon naught Q by R. 1 by 4 pi epsilon naught in MKS unit is 9 into 10 to power 9. Charge Q is given 4 into 10 to power minus 7. And 9 centimeter is 9 into 10 to power minus 2 meters. Let's write this in. So what will be this value? This 9 will cancel out. This is 10 to power minus 5. So you will get 4 into 10 to power 4 volts. So potential due to positive charge is positive. If charge is negative, potential will be negative. Means there will be negative work done in moving a unit test charge at that particular point. So here you have a positive work done in moving a unit test charge. So potential at this particular distance is 4 into 10 to power 4 volts. Now B part. Just see. Obtain the work done in bringing a charge of 2 into 10 to power minus 9 coulomb from infinity to point P. from infinity to point P. So what will be work done? So potential is work done per unit test charge. So what will be work done? Simply Q into V. So this will be given by Q is 2 into 10 to power minus 9 coulomb and V is 4 into 10 to power 4. So this is 8 into 10 to power minus 5 joules. ठीक है? So this will be the work done in bringing charge Q from infinity to point P. From at infinity, potential will be 0. So does the answer depends on the path along which the charge is brought? No, because it's a conservative force. It doesn't depends on path. Clear? It only depends on initial and final position. So it is path independent. So this is the answer of question number 1. Now see question number 2. Question number 2 is, now you have two charges. One is 3 into 10 to power minus 8 coulomb and another is minus 8 into 10 to power minus 8 coulombs. And they are located 15 centimeter apart. At what point on the line joining the two charges is the electric potential 0? Now you have to see at what point electric potential is 0. Take the potential at infinity to be 0. Let's check it. Try to solve. Try to solve it. Now consider let's see, this is charge. Let's say this point is A and this point is B. This charge is 3 into 10 to power minus 8 coulombs. And this charge is minus 2 into 10 to power minus 8 coulombs. And this is 15 centimeter. Let's see at any point P. Now this is point P, which is X distance away. Potential is 0. I'm assuming potential at point P is 0. So if this is X, this will be what? 15 minus X. So when potential is 0, potential due to this charge plus potential due to this charge is equal to 0. So you can write here 1 by 4 pi epsilon naught 3 into 10 to power minus 8 by X centimeter I am taking. So let's take it as X into 10 to power minus 2 meters. Minus of 2 because charge is negative. And this will be 15 minus X 10 to power minus 2. So this will be 0. Now you have to find value of X. Let's check this value. So this will give you 3 by X minus 2 by 15 minus X is equal to 0. And this will give you 45 minus 3X is equal to 2X. So X is 9 centimeter. X is 9 centimeter. Clear? X will be 9 centimeter. Now in this case, I have assumed that point P is in between AB. But you can think of another point that is outside this range, AB. So in that situation, let's see, this is A, this is B, 3 into 10 to power minus 8, and this is minus 2 into 10 to power minus 8. Now let's say this is point P, and this will be X centimeter away. So this distance will be what? X minus 15. So again, at this point, potential will be 0. So potential due to these two charges. So in same way, if you write the equation, what you will get? This will give you 3 by x minus 2 by x minus 15 is equal to 0. So this will give you 3x 2x. So x is equal to 45 centimeter. So there are 2 points where potential will be 0. Either it will be 9 centimeter away from point A or 45 centimeter away from point A along this line AB. So one is 9 centimeter, another is 45 centimeter. So just see, just by equating potential due to both charges will be 0, you will get the value of x. So that is question number 2. Now we have next question. Now see, question number 3. Question number 3. Now in this question, electric field lines are given due to plus Q charge and minus Q charge. So it's a field lines. Figure A and B shows field lines of a positive and negative point charge. And there are 2 points here. One is point is Q, P, another point is A and B. So now just see part A. Give the sign of the potential difference Vp minus Vq and Vb minus Va. Whether it will be positive or negative, you have to check. So, because this charge is positive, so potential is, we know that potential is inversely proportional to R. And this is positive value. So this implies potential at P will be greater than potential at Q. Yes or no? So Vp minus Vq will be positive. So this will give you Vp minus Vq will be positive. Now if charge Q is, because this charge is negative, so potential at A is more negative. VA is more negative than VB. So VA is more negative than VB, or VA is less positive than VB. So it means VB is more positive. So VB minus VA will be positive. Is it clear? Because potential will be negative. So at A, it will be more negative or less positive. At B, it is less negative or more positive. So VB minus VA should be positive. So that's what they have asked. Give the sign of the potential difference VP minus VQ. Now B part. Just see, give the sign of potential energy difference of a small negative charge between the points Q and P and A and P. So if you have a small negative charge, if you place some negative charge, so what will happen? Negative charge will be attracted towards the positive charge, and charge will move from higher potential energy to lower potential energy. So just see. So there is a small negative charge. So a small negative charge will be attracted towards the positive charge. So small negative charge will be attracted towards positive charge. Attracted towards positive charge, and you know that negative charge moves from higher potential to lower potential. Negative charge moves from negative charge moves from higher potential to lower potential. Higher potential energy to lower potential energy. To lower potential energy. So in this case, you will see UP minus UQ minus UP will be positive. UQ minus UP will be positive. And in B part, if you have a negative charge, then you will see you need some external work to place at point A. So at point A, potential energy will be larger because Now you need to do some positive work to move negative charge from any point B to A. So its potential energy will increase. So here potential energy at A is greater than B. So this value will be positive. So this potential energy will be positive because you need to do some positive work. Work done by the external force will be positive. So potential energy of negative charge will increase at point A. But here you have work done will be negative. So that's why at this point potential energy will be high. Here potential energy will be low. Clear? Now next point. Give the sign of the work done by the field. Give the sign of the work done by the field in moving a small positive charge from Q to P. You are moving, give the sign of work done by the field in moving a small positive charge from Q to P. So work done by the external force will be positive. So work done by the field will be negative. So because you are moving a small positive charge, so work done by the external force will be positive. So work done by the external force is opposite to the electric field. So that work done will be negative. So in moving a small positive charge from Q to P by an external force, in moving a small positive charge from Q to P by an external force requires positive work done. Work done against electric field. Against electric field. Thus, work done by electric field is negative. Work done by the electric field is negative. So that is C part. Now in D part, give the sign of the work done by the external agency in moving a small negative charge from B to A. So that will be positive. It is positive. Why positive? Because this charge is negative and you are moving a negative charge. So you need some positive work done by the external force against the electric field. So that's why this work done will be positive. And E part, does the kinetic energy of a small negative charge increase or decrease in going from B to A? Kinetic energy of a small negative charge. See whether it's a you are moving a negative charge from B to A. So it is moving against the repulsive force. So that will try to decrease its speed. So its kinetic energy will decrease. Yes or no? So kinetic energy decreases in going from B to A against repulsive force. Against repulsive force. So because it is moving against the repulsive force, so that's why kinetic energy will decrease. So that is the question number 3. Now see next question. So again you have similar type of question. The two charges are given. Distance is 16 centimeter. At what points on the line joining the two charges is the electric potential 0? So I am giving you the, let's see what will be the answer of this, and you have to try. So this will be question number 4. Let's write the answer. You have to try this. 16 centimeter apart. So one will be 10 centimeter. Answer will be 10 centimeter. And another will be 40 centimeter. You can identify these 2 points. So I have given you answer. You can easily check this value. Okay? Now next question. Question number 6. Question number 6. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. Calculate the potential at the center of the hexagon. What will be the potential at the center of the hexagon? So let's see. You have to find potential due to individual charge. So consider this hexagon, and let's see, this is the center. 10 centimeter. So this is 10 centimeter. And this will be also 10 centimeter. And this is plus Q plus Q plus Q plus Q and plus Q. This will be the center. So let's see, this each distance will be D. So Q is 5 into 10 to power minus 6 coulombs. And distance D is 10 centimeter. 10 centimeter is 0.1 meter. So what will be potential? Potential will be 6 times of Q by 4 pi epsilon naught T. Find out potential due to individual charge and then take scalar sum. So this will be 6, 1 by 4 pi epsilon naught is 9 into 10 to power 9. Q is 5 into 10 to power minus 6 and D is 0.1, and this will give you 54, and let's see, into 5, and this is into 10 to power 4. So this will be into 10 to power 4. This is 2.7 into 10 to power 6 volts. This will be the potential at the center of the hexagon. Clear? So simply case of 6-point charges, find the potential due to individual charge, take scalar sum. Now you have two charges, 2 microcoulomb and minus 2 microcoulomb are placed at points A and B 6 centimeter apart. Identify the equipotential surface of the system and what is the direction of the electric field at every point on this surface. So answer 6. Let's say this point is A, this is 2 microcoulomb, and this is minus 2 microcoulomb, and this is 6 centimeter. Identify the equipotential surface where the potential will be same. Now you should draw, if you are, let's say this is the midpoint, draw a plane. Let's draw a plane just perpendicular to AB. This plane at midpoint, this will be at 3 centimeters. So draw a plane perpendicular to the line AB. So on this plane, potential will be same because they have the, this will be 2 plus 2 microcoulomb. This is minus 2 microcoulomb. So at this point, potential will be same, and from here also potential will be same. So this plane is located at the midpoint of the line AB because we are taking the same magnitude. And what will be the direction of the electric field at every point on this surface? So electric field will be perpendicular to it. Just draw perpendicular L in the direction from A to B. This will be the direction of the electric field, perpendicular to equipotential surface. And this will be directed from positive charge to negative charge. Clear? So electric field will be perpendicular to the equipotential surfaces. If potential is, if you draw the equipotential surface, electric field will be perpendicular to that. Now you have to solve question number 7. Now this you have to try. This is based on electrostatic energy or potential energy of a system of charges. So 4 charges are arranged at the corners of a square of side D. Find the work done required to put together this arrangement. This is A part, and in B part, a charge Q naught is brought to the center E of the square. The 4 charges being held fixed at its corner. How much extra work needed to do this? So what you have to do, you have to find work done in placing individual charges, and then you have to sum up all those works. So that will give you the potential energy of that system. Okay? So you have to try this question. In next lecture, I will discuss the solution of other questions. First you should try, and then we will discuss it. So find, let's say you have placed first charge. So what will be work done? Then second charge, third charge, fourth charge. And then finally you have to see work done in placing Q naught. So try to solve this question. In next lecture, I will discuss its solution. Clear? I will discuss, now I will solve all the problems related with each concept. So you should see the summary, and if you still have some doubt, you should go through the standard book and please revise it and try to solve the question, because through questions only you will learn the concept also, and you will be able to solve problems. So that's why I'm focusing on summary and then problems. Through problem you should clarify your concepts. Clear? Chalo, meet you tomorrow same time. Thank you everyone.